Welcome to Algebra 2. Today we've got section 11.3, collecting data. So this has hopefully been kind of a nice chapter for us. I know I certainly have enjoyed it. But being able to focus on vocabulary, right, and it's not as math intensive, and really something that's so applicable to the real world. We've had a lot of examples and problems that have come up, and they look just like headlines we might read in the newspaper or online. And kind of being able to evaluate a lot of these things that we encounter in the real world is a really useful skill. I think it makes us better informed citizens here. So not to get all political or I'm not teaching a social studies class here, but it's really useful math. So let's talk about how we collect data. Okay, we've got a lot of information here that I'm going to present, and we're just going to kind of practice this vocabulary a little bit, I guess. That's what this section is primarily concerned with. So a lot of times when you see a survey or like some type of data or statistics that come out on a certain topic, it's based off of a study or some type of sampling survey. It's important to know how those surveys can occur. So here are the steps that in a typical survey, here's what it should go. Identify the variable, choose a sample that represents the population we're concerned with, collect the data, organize it, and then interpret it. So we're going to look at the ways that we can sample a population, okay? Because we want to be able to get this statistic and have it be representative of the population. So more than likely, we want a random sample, okay? Each member of a population has an equal chance of being selected, so we're likely to have a sampling that does represent what the population looks like. Okay, now here is a little diagram, and I think I can move my recording window over here, fit everything on the screen. So look at the types of samples. For a self-selected sample, members of a population can volunteer to be in it. This is what I would consider to be like if you're looking at Amazon.com or ordering something online, they have customer reviews or restaurant reviews you see pop up online too. Think about who is going to choose to be in the sample. Who's going to take the time to actually survey or review that product or do something. Chances are that it's the people that are strongly against it or that really, really liked it. So you're not going to get your average result there, only the people that are really invested in making their opinion known. Then you got a systematic sample where you use a rule to select members of a population. And here they say selecting every other person. Yeah, you're choosing specific people out of that group, but just a rule. A stratified sample, this is one where you may look at the population in general and say, okay, I've got this many males, this many females. I've got these 3 age groups. So we would take our population and divide them into smaller groups that share characteristics. Then you randomly choose your people from those groups so that you know you're including every group. You can also use a cluster sample where you're also dividing into groups, but you choose all of the members in one or more of those clusters. And if you see the little arrow off to the right, then it shows that you cannot count people twice. You're taking one cluster and looking at that only. Then at the end, a convenience sample, only members of a population who are easy to reach are selected. So it may be, okay, we want to survey everybody in the community, so we'll conduct a survey here in the school because that's easiest for us to get feedback from. Okay, so you don't think about this when you read like percentages or data or statistics in a headline or something like that. You don't think about all that went into collecting that data, and seeing all the different ways that we could have chosen people to collect that data should make us a little suspicious about what we read. Recording window back into place over here. All right, one of the major issues with taking a survey or something and using a sample is biases. A bias, I'm sure you've heard that word before, It's the result of misinterpreting or maybe having, your survey only includes people that have strong opinions in favor of something or not, that have strong opinions of it. We want an unbiased sample. So this is one where it includes all, it's representative of our population, but it has people that will simply answer yes or no, that they don't have a strong bias one way or the other. And when we do have a biased sample, we can't really trust the data. So that's why having a random sampling somewhere in our process helps reduce that possibility, because we are randomly selecting people, not just having people that have strong opinions answer that survey. Now, we're not going to be designing surveys ourselves, but again, think about what went into making a survey. A lot of times biases come as a result of how questions are worded. So we'll see examples of this later on when we get into the lesson, but we don't want our questions that when you read them, they encourage a response. We don't want questions that are too sensitive to answer truthfully, maybe the context that they're asked are real sensitive issues where people might not answer those honestly. They don't provide enough information, so there's confusion on the part of the person taking the survey, and that they address more than one issue at once, right? We want our data to basically boil down to yes or no's, so we can get that data associated with our sample. And if we have any of these issues happening, we won't be getting accurate data based on our sample. All right, so sorry I'm talking an awful lot, but again, it's mainly vocabulary. So how can we collect data? We could use an experiment, we could observe, we can take a survey, or we can run a simulation. We saw a simulation with our coin that we suspected favored one side in the last section. A survey, pretty self-explanatory. Observational study, this is like a clinical trial or things like that, where you're observing and measuring without the individuals really knowing it, without having any effect on them. You'll see this a lot in psychology, observing people's behaviors. And then an experiment, this would be also like a medical situation where you have a control group and you're looking for effects there. But those are the different ways that we can collect our data from our sample. All right, so that was a lot of information. I hope you're not feeling overwhelmed. You certainly shouldn't. Those are just all things that we can consider, that could have gone into this survey or experiment or observation. So when we look at the data, we want to be able to analyze it a little bit further. That's the purpose of today's lesson. So example 1, identify the type of sample that they described. So we can go back in our notes and look at the one with all the pictures of the people there and just decide what type of sampling are they using here. Number 6, each employee in a company writes their name on a card and places it in a hat. The employees whose names are on the first 2 cards drawn each win a gift card. All right, now notice, they did not say that people voluntarily sign up. They said each employee in a company writes their name. So everybody's included, and then they draw the cards out of the hat. It is entirely random. That is a random sampling. Okay, they didn't break it down into groups or anything like that. It was all random. Number 8, the owner of a community pool wants to ask patrons whether they think the water should be colder. Patrons are divided into 4 age groups, and a sample is randomly surveyed from each age group. Okay, so here we divided all of these pool patrons into groups, and then we chose from each age group. We didn't choose a particular age group to ask, randomly chosen from each age group. This is a stratified. Sample because we're incorporating data from each group, but we also divided it up to make sure that we did get input from each group. This one's kind of tough to distinguish from clustering. What a cluster would look like here is if they had split the patrons up into age groups and then only sampled one of those age groups. So this is stratified because we're incorporating each of them. Okay, identify the type of sample and explain why it is biased. So these are both biased samplings that are occurring, and we want to explain why that is happening. Number 10, a sports writer wants to determine whether baseball coaches think wooden bats should be mandatory in collegiate baseball. So the sports writer mails surveys to all collegiate coaches and uses the surveys that are returned. Well, this is definitely biased. We can clearly tell that. It is a self-selected. Okay, it's a self-selected survey, so people can choose to complete this survey or not. And the bias that causes is only those coaches with strong opinions about the topic will respond or are likely to respond. Just like if you order something online and it's just kind of, okay, yeah, it's what I expected, you wouldn't feel compelled to review this as being, it was an average product. You just kind of deal with it. Same thing is happening here. It's self-selected. Only the coaches that have really strong opinions are going to fill out that survey. I think they should ban metal bats. Oh, I think metal bats make the sport more engaging at the collegiate level, something like that, make it more competitive. Only those types of responses are going to be turned in. So definitely a biased opinion with a self-selected sample. Number 12, every 10th employee who arrives at a company health fair answers a survey that asks for opinions about new health-related programs. Okay, this is a systematic sample. Okay, and we can tell that it's systematic because they have a rule for choosing what people are going to participate in this survey. In this case, it's not, do you choose to take a survey or not? It's you're one of the 10, you're the 10th or the 20th person, whatever that arrives at this health fair. You're going to take this survey. So there's a rule for choosing who takes the survey. Okay, and then it asks for your opinions about a new health-related program. Well, the bias here is that you're at a company health fair. So the people that are showing up to that health fair are going to be ones that don't necessarily have the same opinion about health programs that your average employee would. Maybe there are a bunch of employees that didn't show up at this health fair. So it's systematic, and because of the fact that it's at a health fair, the bias occurs. Oh, is it 1 hour or 2 hours? Oh, my English comes back to haunt me again. The bias happens because you're only surveying employees that are attending the health fair. Okay, so yes, you are getting a random sampling, but think about what's going into that sample. It's only people going to the health fair. If they said that this was a mandatory company health fair, then there probably wouldn't be any bias. It would be a much more random sample. Okay, so now we're looking for biases. Maybe it is, maybe it isn't, and explain why or why not. Number 16, a governor wants to know whether voters in the state support building a highway that will pass through a state forest. Business owners in a town near the proposed highway are randomly surveyed. Well, this one is definitely biased. Hopefully we don't have to read that too carefully to realize that. If he wants to find out if voters in the state support building a highway, he shouldn't just ask business owners. He should ask everybody, or randomly survey everybody in that town. So it's biased because only business owners were surveyed. Chances are that the people that own businesses there don't necessarily have the same opinions on this topic than the general populace. Number 18, your school principal randomly selects 5 students from each grade to complete a survey about classroom participation. Okay, principal randomly selects 5 students. It's not optional. It's not something that students get to choose to do or not. Selects 5 students from each grade. You're taking the survey. Okay, this one is unbiased because the entire population is represented. Right, we're getting a random sampling of students all throughout the school. We've got all grade levels represented. And again, it's not people that are choosing. He's not randomly selecting 5 honors students or randomly selecting 5 members of the student council or anything like that. We're not talking about a specific group. We're talking about the entire population that could be chosen to take this survey. Okay, now we're going to look at the questions that may lead to biases. Look at number 26. Question is proposed, would you rather watch the latest award-winning movie or just read some book? So if you imagine this was in a survey or something that you're handing out, when you read that question, you see words like a latest award-winning movie and some book. They're clearly trying to encourage you to favor the movie. So this is causing some serious bias. Encourages response in favor of the movie. So that's why it's biased, or why it could be biased. Now, how do we correct that flaw? How could we compose a question that would be, I don't know, that would get us the responses without encouraging them, without swaying the responders one way or the other? How about just, would you rather watch a movie or read a book? So just by rewording the question there, we get rid of all those adjectives like latest, award-winning, or just some. And you kind of pare that question down into something where it's a simple yes or no answer. The reader is not encouraged to answer one way over the other. And lastly, number 28, a child asks, do you support the construction of a new children's hospital? Well, this one is biased in a way because of how they're asking the question, how they're conducting the survey. So responders may not answer truthfully. If a little child comes up and says, would you support the construction of a new children's hospital? Even if you were against that, because you're answering a child, you may be more likely to say, oh, yeah, I do, even if you truly don't support that. So the fact that a child is asking the question for a children's hospital, it might affect some people's responses and kind of take away from the validity of that. So how do we correct the flaw? Survey in a more anonymous way. So maybe the people that we're choosing to take this survey, we just have them fill out a sheet of paper or something like that, not a child or not a doctor, or something that may sway the survey taker's answer. Kind of neat, things you don't think of when you read a headline or see a statistic or something like that. You don't think about all that happens behind it or what may not have happened. Here's a look at your assignment for this section. Again, not a lot of math, but a lot of vocabulary, analyzing these studies and surveys and experiments.